Now let us dive deeper into our lesson. So in wrapping up our lesson on factorization, we're going to touch perfect squares. Now perfect squares is another unique form of factorization. So one of the unique things about it is that it comes in the form of a squared plus 2ab plus b squared. So that's the form that it comes in. So when we look at this, is that these two, this a and this b are literally the same right here. So we're going to actually have a breakdown of what that really is. So if you when it comes on the perfect square, it is actually, when you look at this, for example, a plus b squared. So this is literally a form of a plus b squared. Now, one of the things that students will actually sometimes mix that up or write this or rewrite this as a squared plus b squared. Just like in the example of the difference of two squares, where the only difference between the two would be the negative. But this is not accurate. This right here is that a plus b all squared does not equal to a squared plus b squared. So I'm going to literally explain that to you, how different they are. Now I'm going to have a breakdown explaining the difference between the two. So looking at one, I'm just going to come over here a little bit. So I have a squared plus b squared on one side, and on the other side, I'm going to have a plus b all squared. So let us give a to b the value of 2. So we're saying 2 squared plus, and we're going to say that b is 3. 2 times 2, to our 2 to the power of 2 is going to be 4, and 3 to the power of 2 is going to be 9. And 4 plus 9 gives us 13. Now when we have this now, what this is literally saying is that this is saying a plus b is being multiplied, is being squared. So a plus b is being squared. So a plus b times a plus b. It is just the same as saying 2 in brackets squared. All I'm saying is that 2, 2 times 2, which is literally 2 times 2. But the fact that there is a sign between makes a little difference right there. Squared equals 2, sorry. So this would be, so having this all squared, is literally saying, yes, the equal sign. 2 plus 3 and 2 plus 3. So that is literally how it is written out. So again, as we said before, is that a is 2 and b is 3. 2 plus 3. So 2, just to see what we're doing with the markers. So 2 times 2 is going to be 4. 2 times positive 3 is going to be 6, right? 3 times 2 is also going to be 6, and 3 times 3 is going to be 9. So we can see that these two, as we said before, that when we have a squared, so we have a squared, you realize that 4 is a squared number, and we said that plus 2ab. If you realize 6 and 6 are the same thing and they are going to be added together, plus b squared. You say, look now that this is a squared number and this 2 is a squared number. But these 6 and 6, they are not squared number, but instead, they are literally the same number being added together. So I just wanted to point out how the format actually works. So in adding this, so 4 plus 6, that's 10, 10 plus 6, that's 16, and 16 plus 9 gives us 25. So there you have it. That's a vast amount of difference between a squared plus b squared and a plus b all squared. So perfect squares is this one right here. This one is perfect squares. This one is not perfect squares. So I just know I need to identify the difference so we can just take a look at it. All right, so let us take a look now at this example of perfect squares. So we have 5x plus 2. So 5x plus 2, as I said before, we're just going to, whatever's in the bracket is being multiplied by itself. So that's 5x. So that's 5x plus 2 times 5x plus 2. Right? So here, when we look at it, this right here, just going to use a different marker so we can see what's happening. So here, multiplying this 5x is going to give us 5x, sorry, it's going to give us 25x squared. And then this 5x is going to multiply the 2. It's going to, 5 times 2 is 10. So that's a positive 10x. Again, now we're moving along. So this 2 is going to multiply here. It's going to give us positive again 10x. And then again, we have this 2 right here is going to multiply this 2 and it's going to give us 4. So again, if you look at the 25 is a squared number, and if you look at the 4, that 2 is a squared number. So here we again, just like the 6 and the 6, the 10s are literally written out as the same. So if you look at the form that I gave you initially, where I said that it is given in the form of a squared plus 2ab plus b squared, you're going to see that literally right here is a representation of 2ab. A squared b is also squared. So that is literally how it is given. And when you actually work it out, you can see it for yourself. Right? So in solving, we know that these are not like terms. As I defined like terms in the initial video, where I said that once the variables are the same, and if the index are not the same, they are not like terms. So these two cannot be added. But these two, the variables are the same and the index are also the same. It doesn't matter the coefficient. The coefficient does not determine whether or not it's a like term, but the variables do. So 10 plus 10 is 20x. And remember that when we're adding algebraic expressions, when we're adding like x and x, adding x and x, I don't change the power to 2 or anything. Sometimes students make that mistake. The only time you do that is when you're multiplying. So that's 10 plus 10 is 20x, and then plus 4. So there you have it. And if you look closely, you will notice very much that looks literally just like your trinomial, because the truth is that this is really a trinomial expression. If we were to work that out using the trinomial expression that we talked about earlier, we could get back our expression. So remember that the first step in doing our trinomials is a times c. So 25 times 4 is going to give me a positive 100. In listing out the factors of 100, I need to find two numbers that when added together gives me positive 10. And remember, this is a positive 100. So with a positive 100, it means that these two numbers must also either be two negatives or two positive. Now, since it's a positive 20x, the two numbers will be a positive. So looking at it, so we can write back 25x, and the pair would actually be, if you were to list out the factors of 100, the only pair that gives me positive 20 would be 10x plus 10x, and then plus 4. So this is literally working it backwards. And as you can see, if we were to look at these two terms, what is the highest common factor between 25 and 10 is 5, and we're going to take the x with the lower index. So 5x into 25, 5 into 5 is 5. X is going to cancel out one of the x's. It's going to change the marker so we can see what's happening here. So the 25 into 25 goes 5. X is going to cancel out one of the x, gives us just 1x. So I'm left with 5 and x, 1x, or x to the power of 1. Plus 5 into 10 goes 2 times, and the x is going to be cancelled out. And here we're going to have a positive. What is common between, what is the highest common factor between 10 and 4? That's going to be 2. And we can't take out the x, so we're just going to leave it there. So here now you have it, that 2 into 10 goes 5. Can't do anything with the x, so we just write it back. 24 actually goes 2 times. So there we have it. In the reverse is 5x plus 2. So we have 5x plus 2, and we're just going to group it as 5x plus 2. There you have it. So that actually takes us to the end of our lesson in solving factorization algebraic expressions, right? Thank you for tuning into this math lesson. I hope this was very informative. Please remember to like and share this video, and also subscribe to my channel where you can get the latest math updates. Also check my description to see my website where I'm actually selling books where you can practice and study. And again, thank you very much for tuning in. Have yourself a wonderful day. Thank you.